So in this lecture, we're going to be looking at the relationship between perpendicular gradients. So what we have here is we have two lines, each with their own gradients. One is 3 over 2 in this direction, and one is minus 2 over 3 in this direction. So the relationship between these two lines is that they meet each other at right angles just here. And what we're going to see now is if we change the values of the slope, but keep this constant relationship of the lines being at right angles, you'll be able to see a relationship between the two. So we've now changed the slopes to this one is 6 over 7 and this one is minus 7 over 6. And what you might be able to start noticing, I'll change it to this one, minus 3 over 2 or 2 over 3. You'll see that the slope of one is always the same as the slope of the other, except it's been flipped over and the sign's been changed. And you can see for any value of the slope, it's always going to have this relationship. If this is 2, this is going to be the inverse and taking the negative. So now I'm going to show you the maths behind this relationship, and I'm going to show you how to solve problems using it. So to prove the relationship between the two lines, what we're going to do is take this triangle here, which we're interested in the gradient of the line OA, and we're going to rotate it by 90 degrees. 90 degrees. So these two lines are now perpendicular to each other. I'm going to work out the gradients for both of these, and then we're going to see what the relationship is between them. So we'll first work out the gradient for this line OA. I'll do this in a different color. Okay, relationship of MOA, which we know is the change in y, which is S, and the change in x, which is R. Then we want to know the gradient of this line now. It's been rotated 90 degrees, so that's MBO. MBO, which is equal to, now because this has been rotated backward, this is the negative, this is now a negative sign, so it's now negative S. No, my apologies. Because now the S is now the X component and the R is now the Y component. So it's R over negative S. So what will happen if we multiply these two together? So if we multiply these two together, we're going to get a constant value, which you'll see in a second. BO. So that's equal to S over R times R over minus S. The R's cancel and the S's cancel. So all we're left with is this negative 1. So, and this leads us on to the statement that all that any gradient times any gradient that's perpendicular to it is always going to be solved in that slides earlier. So you can now see again that if you times these two numbers together, you're going to get negative 1. If you times a negative 2 by a half, you're going to get negative 1. If you times negative 4 by a quarter, you're going to get negative 1. It's always this same relationship, and we can use this information to help us solve problems.